Okay, so what I want to do in this lesson is I want to start talking about the next phase of the star's life cycle. So this is, for example, when a red giant, when the star goes from a main sequential star to a red giant and what actually happens there. So we're going to talk about phase 3 in this case. So phase 3. And phase 3 is what's known as the red giant. So what we want to kind of think about is, so we have this process here, and so we have, like, let's say when a star kind of starts to form, and you have a core, and in the core what's happening is gravity is compressing everything together, and when particles are compressed together and they're moving around and they're spinning around, the temperature increases, and when the temperature gets up to sufficiently high, what's going to start happening is the hydrogen core is going to start fusion. You're going to get a fusion reaction happening. So you're going to get hydrogen atoms being compressed together, creating helium. So remember, if we think about the periodic table, we have hydrogen being, so when you have two hydrogen atoms compressed together, you get helium being formed. And what's going to happen then is helium is going to start to build up, let's say, within the core. So helium, if we look at helium, for example, on the periodic table, it's a bigger and denser element than hydrogen. So following on from that, then I just want to kind of give you an idea of what starts to happen. So imagine then we have the core. So this is the core. And then within the core, what you're going to start getting produced, you're going to get helium. So we'll just write He, so helium. So imagine then within the core, you're going to get more and more and more helium being produced. So what's going to happen is you're going to get this dense core of helium. And with this dense core of helium, the pressure and temperature is going to even go up even more. So temperature and pressure is going to continue going up. And what's going to happen is gravity, the force of gravity is also going to go up as well. So gravity is just going to be pulling everything in towards this dense core. So imagine you have this inner core of helium being formed, which is a bigger and denser element. And as a result of that, the size of the core, the radius of the core decreases. So you get the core starts to actually shrink because it's being compressed together more. And then imagine then on the outside here, so the temperature is going to go up. So you're going to get more and more, let's say, hydrogen. So imagine you have hydrogen then around here. So you have hydrogen. So hydrogen is still part of the core, but in the middle now you have helium. And as a result, what this is doing is it's increasing the temperature and it's increasing the pressure. And you're going to get more fusion of helium outside here. It's going to actually happen faster and more rapidly now because of the stronger gravity being produced by the heavier element, which is hydrogen in the core. So you're going to get fusion is going to happen rapidly. And what's going to happen is this is actually going to, so you're going to get more and more energy and light being expanded out. But what this process will do is, and you're going to get more hydrogen being fused into helium. So this core is going to get, the hydrogen core is going to get denser and denser and denser and denser. And as a result of that, what's going to happen is more and more hydrogen is going to be fused out here, let's say. So it's like there's a shell of hydrogen around the helium core, and it's being fused, and the helium that's generated is being compressed into the core, and all this energy is being let out. But this is happening faster and faster and faster. So what's starting to happen then is the radius, the outside radius of the star, it actually starts to increase. So you get this bigger and bigger radius being formed. So the core gets denser and denser within here, but the radius around the star starts to increase. So you can see here, so you have the sun here, for example, and when all of the helium starts to, when you get sufficient helium being produced, then you start to get a core of helium, and then it starts to fuse hydrogen. For example, hydrogen starts to get fused even more rapidly out around here on the edges. And this causes the size of the star to expand and to increase, like so. And what you'll actually get is, you'll get, if you were to take, for example, the temperature within the core, the temperature in the core is going to be much higher than the temperature, let's say, within the core of this star. But if you were to take the temperature out here, let's say out along the surface, it's going to be a little bit cooler than the temperature, let's say, around the surface, let's say the temperature here within this star. So essentially then what you get then is you get this stable kind of configuration where you have, so imagine you have a hydrogen core. So you get this hydrogen core being created. So imagine this is a hydrogen core, and then around that then you have, sorry, a helium core should I say, and then around that then you're going to have hydrogen. So imagine, so in here is helium, here's hydrogen, and fusion is going on here all the time. So this hydrogen helium core is getting bigger and bigger and bigger, and it's getting denser and denser and denser. And then what's going to happen is you're going to get a much bigger radius around the star. So you're going to get this bigger radius, if you like, around the star. And this here then is what's known as a red giant. Now, also as well, what can happen is, depending on, so this is where you're going from this process, you get a red giant being formed, but depending on the amount of, let's say, hydrogen that you start off with, if you start off with a huge amount of hydrogen, much bigger than what you start off if you go down this route, you will get like what's known as a red supergiant. So it's just similar to this, but it's just much, much, much bigger, and much bigger, and has much more fuel, and it burns for a longer period of time. So phase 3 then, so when the star has used up all its supply of hydrogen in the core, it begins to burn helium on its outer parts. This causes the star to release more heat, and as a result, the outer parts of the star expands. So that's kind of like what you get happening here. The star now becomes a huge structure and is known as a red giant. When the sun becomes a red giant, it will engulf and destroy the Earth. Scientists believe this will take place, but not until around 5 billion years from now. So this is the fate, if you like, of our sun. This is going to happen. So when the hydrogen, when this hydrogen fusion starts to reduce, and you start to get helium being produced, and you get this helium core, what's going to happen is our sun is going to expand out, and when it expands out, it's going to engulf the whole, like all of our planets in the solar system and Earth. But that's not going to happen for a long time. So we're talking about 5 billion years. So 5 billion years before that actually starts to happen. Now, what's really interesting then as well about this is that when this core here starts to get sufficiently big, what's going to happen is you're going to get the helium, you're going to get fusion of helium. And when you get fusion of helium, you're going to start to get another core starting to develop, let's say, within the star. So you'll get a core. And what starts to happen is when you start to fuse together the nuclei of helium, what you start to get produced then are other elements such as oxygen and carbon. And carbon and oxygen are two very important elements to us, for us. Like carbon is like the building block and the cornerstone, if you like, of all of the molecules that make up our body. And oxygen is an important element that we need to breathe and to be able to breathe as well. And it forms a part of our atmosphere around our Earth as well. So what we get then is when helium starts to fuse, when the conditions get just right, let's say within this red giant, what will start to happen is you'll get the fusion of helium, and that will combine then to make other elements such as oxygen and carbon. So if we have a look here in the periodic table, so you have helium, it has 2 protons within its nucleus, and when these combine together, you can get oxygen, which has 8 protons, and you can also get carbon, which is 6 protons. So imagine if 3 of these helium atoms combine together, you're going to get oxygen, and then if you get carbon and helium combining together, you're going to get 8 protons, which will give you oxygen as well. Now that's a very simplified version of what happens, but we can kind of get a sense then of where we get these other bigger elements. So where these bigger elements are, how they're formed and where they've actually come from. So that is the process then. So that's, let's say that's phase 3. That's where you get these red giants formed and how they form. So, and that's this phase here. So what we'll do in the next couple of videos, we'll start to look at these other phases that can start happening then as well. Okay, so thank you for listening.